In this last module, we are going to look at risk mitigation, risk monitoring, and risk review. Risk mitigation is the action of reducing the severity, seriousness, or painfulness of something. Let us see how we could mitigate the risks we have seen in the above scenario. In the scenario pump room plumbing, there are various hazards that the plumber will face while on site. Did you see a few of these hazards and risks? Well, here are a few. For one, we needed to work at heights. Remember that 3-meter wall that we needed to climb up in order to get the feed pipe from the pump room down to the actual feed source? Well, are you going to use scaffolding or a ladder? Well, that initially would be your hazard. The risk would be the potential to fall to a lower level, or the potential to drop tools or material to a lower level, and the consequences of which could be fatal, serious injuries, damage to tools, as well as the materials. Another hazard would be the hot works or welding. This could be the actual copper pipe that needs to be welded together. There is the risk here of fire, as well as the consequences being fire, which could cause damage, it could cause burns, as well as the damage to tools or materials because of this risk. There is also the hazard of using a drill for the drilling of a hole. This is the portable electrical side. So using electrical tools obviously also creates a hazard, the risk of which is the electricity, the vibration, the sharp points, dust, as well as debris. The consequences of which can cause electrocution, vibration injuries to muscles and bones, puncture wounds, inhalation of dust, flying particles, debris causing injuries and eye injuries, as well as waste accumulation. And lastly, we think of manual handling. This could be dropping materials, sharp edges, or ergonomic related risks, such as bending and stretching. The consequences of which could be serious injuries, damage to tools, as well as materials. Now, this list should always be in a priority of action method, the highest risk at the top, so that we can mitigate the highest risk areas first. This is just the way we perform it, so that high risk environments are cared for in the beginning. However, some sites request that your risk assessment be performed in a step-by-step manner. In other words, the drilling of a hole might come before the use of scaffolding, as this can be done on ground level inside the pump room and drilled through to the outside of the exterior wall. The manual handling might be twofold or threefold. The manual handling of setting up the site, then setting up the actual scaffold or ladder, and then the manual handling of the equipment itself during installation. Regardless of how you perform this, please remember to isolate and identify the hazard. Evaluate the risk carefully to identify what the consequences could be so that you can put your risk mitigation controls in place. Please remember that these risk mitigation strategies must be developed through a proper hierarchy of control. You see, we want to start with the most effective solution before resorting to personal protective equipment. Things like physically removing the hazard, trying to eliminate it completely. If this is not possible, we then see if we can substitute or replace that hazard with a less hazardous or safer method. Then we look at engineering controls, isolating people or isolating the hazard. We then also try and change the way people work through administrative controls by giving them a safe working procedure. And finally, but also mandatory, is ensuring correct, appropriate, and safe personal protective equipment for all employees. In the next course, you will be able to perform a risk assessment using this risk matrix. The risk matrix helps us to understand the severity and probability of the risk that we have just assessed, and find out whether it will be an insignificant, minor, moderate, major, or catastrophic severity, as well as the likelihood being very unlikely, unlikely, likely, very likely, or almost certain to expose us to danger. This will then put us into one of three categories: low risk, medium risk, or high risk. Then we want to use our effectiveness of controls, which you can see is based on the hierarchy of control, starting with the elimination, then moving to replacing, substituting, transferring, then isolating your engineering controls, limiting the exposure through administrative controls, and finally resorting to personal protective equipment, each with its own percentage of effectiveness. Remember these definitions when deciding on the hierarchy of controls. Elimination is the complete elimination of the hazard by design. Substituting or minimizing the hazard is either replacing the hazard, material or process with a less hazardous one, or significantly reducing the magnitude or severity of that hazard or materials so that the consequences are also greatly reduced. Engineering control methods are designing in controls or redesigning the equipment or work process itself. Engineering controls can also include the separation of the risk, such as placing a physical barrier on the hazard or guarding or enclosing it to protect others. Administrative controls provide controls such as training as well as procedures. And finally, we end on PPE, personal protective equipment. Please remember that when it comes to PPE, we need to use appropriate and properly fitted PPE, not just any PPE. Let us now apply these risk mitigation strategies to the task in the scenario that we've just spoken about. The first hazard we looked at was heights, with the potential to fall to a lower level, dropping tools or material to a lower level. So now we need to ask ourselves, can we eliminate, substitute, engineer a control, implement administrative controls, or provide PPE to mitigate this risk properly? Well, let us ask these questions in a step-by-step format. Can we eliminate the working at heights aspect of the project? Well, in this case, we say no. We have to access that area outside the wall in order to attach a pipe to the wall. So we move on to the next hierarchy of control, risk mitigation, such as substituting. The question here is, will we be able to change the working at heights with a different type of hazard? In this scenario, we cannot substitute working at heights. What we are able to do is substitute the amount of time spent on the risk of working at heights. For instance, we could install the one end of the bend to the upper part of the piping so that only one end will need to be connected once we are at heights. This will minimize the amount of time spent at heights and lower the risk, as the plumber will not be exposed to the hazard for as long as we thought. Even though we have lowered the risk to a degree with our substitution method, we do not stop there. We must move on to the next hierarchy of control, in this case, the engineering controls. And you can ask yourself, are you able to isolate the hazard or isolate the person from the hazard? Well, what would be more dangerous? The use of a ladder at 3 meters or the use of a scaffolding? Obviously, we know that the use of a ladder in this scenario would definitely be a riskier choice. So is there a possibility that we can mitigate the risks by choosing the less risky option of a scaffolding? If so, we have just arrived at a vital point in safety management and risk mitigation. We have achieved a safer method of working, and as we continue to make it more safe, we will eventually reach an acceptable risk level where we can work with the lowest risk rating possible. But it means we still need to carry on mitigating the hazards and risks. So let's continue. A scaffolding setup that is safe gives the plumber the protection of a barrier from the fall risk, as opposed to the latter, which has no barrier or guardrails to prevent the fall, thus isolating the person from the risk. Now, at this point, we have arrived at a potential solution to our hazard of working at heights and have brought the risk to a medium rating. This is acceptable in terms of the actual hazard and risk, and we would be able to continue working. We must, however, remember that the lower part of the hierarchy of controls has not yet been considered, and we are trying to make sure that the working environment is as safe as possible, as well as low as reasonably possible. We will still want to consider these aspects, as we have not reached a fully mitigated risk just yet. The next hierarchy of control then is considered. This is administrative controls. Administration includes all forms of documents, such as plans, procedures, certifications, and the like. This does not mean that we didn't have a safe scaffolding during the engineering controllers application, but it is expected that any form of control has the necessary compliance documentation in place. Now, this supporting documentation forms part of your administrative controls to emphasize what we have in addition to the above controls, including any documentation that will be needed with the above. This could be additional measures such as toolbox talks, daily safe task instructions, or planned task observations. And finally, we reach the last of the risk mitigation methods in terms of a hierarchy of control. This is personal protective equipment. This is always a mandatory item, much like administration of a document body of proof. PPE must be specific to the risk as well as fit for the purpose. It must be fitted to the plumber who will use it, as it becomes personal equipment, and as such has to fit right and have the best protection for the plumber. Do proper research to find the right type of PPE and also the most suitable PPE for the task you are performing. We'll now look at the rest of the items from 2 to 4 in your workbook and determine what would be the best control for each hazard. Remember, we've already discussed working at heights on a ladder, and we've identified the risk to falling to a lower level, dropping tools and materials to a lower level, but we've come up with specific risk mitigation strategies, and this we are going to put in our control column. This is a safe scaffold set up in accordance with SANS 10085. We are going to ensure competent plumbers, these who have certifications in heights and the use of scaffolding. We're going to limit the time spent on the scaffolding by ensuring that they do a lot of the work on ground level and then take it up to do the installation. We are also going to ensure all documentation is in place, fall protection plans, risk assessments, and then finally our PPE, ensuring a full body harness is used in addition to the scaffolding. Also, we want to include a hard hat, safety boots, overalls, gloves for handling the material, as well as use of personal protective equipment when they're using drills as well as grinders, safety glasses, dust masks, as well as ear protection. Why not take this time to pause this course and go through the next 2 to 4 items within your workbook and take a look at how you can first of all determine whether the risk is appropriate to the hazard that we've discussed, and then what control measures would you put in place, considering the hierarchy of control as well. Let us now discuss the risk monitoring part of a risk management program. Risk monitoring means to observe and check the progress or quality of something over a period of time, keeping under systematic review. Well, you have now started the project and all the above risk mitigation is in place. Your safety file audit went well and the client has given you permission to start the project. Does this mean we no longer need any safety management since we've covered all the items in the control section of risk mitigation? Not at all. safety is even more vital now. Since you've achieved acceptable risk levels, that means there are still risk levels. And if there is still risk, we need to identify if the control measures we've put in place are actually being carried out. It means that you need to periodically inspect whether the control measures that are in place are actually being performed. Now, dependent on the risk rating of your residual risk, you will monitor these at different intervals, more frequently for higher risk and less frequently for lower risk. Let us consider, though, our initial hazard, that is, working at heights. Now, on our scaffolding, we've made it safer than just working on a ladder. The risk is still there, the fall to a lower level, the dropping of tools and materials to a lower level, although it's a lot less because you've enclosed the area of work, you've provided guardrails and a suitable platform to work on, you've also provided toe boards to prevent tools and things from falling over. So even though the likelihood has been minimized, there's less chance of these hazards from exposing us to specific risks. There is still the potential for risk. And so now we need to take a look at our control measures and how we monitor this to ensure it's effective. This can be done by daily inspection of the scaffolding by a supervisor. Why daily? Because the law requires a weekly scaffolding inspection. Well, daily inspections are better than weekly because things change all the time. And so why settle for minimum? Why settle for the least amount of protection? Is it possible to do a daily inspection on that scaffolding, set up for just a week perhaps, in order to fit one pipe on the outside of a building? Well, it is possible. It just takes a little bit of time. Time you have, lives are not. And so take the time out to do a daily inspection. Do daily inspections of your harnesses, your PPE. Do your monthly file audits, 3 monthly risk assessments, your 6 monthly review of fall protection, annual medicals, as well as 2-year working at height certifications. All of this monitoring will determine whether the control that you put in place is actually effectively being carried out and not just put in place for documents on a safety file, and once you've been audited as competent and allowed to work on site, then safety stops there. You need to prove that your safety system is a living, breathing thing. Now, with this monitoring and risk monitoring section discussed, we'd like you to look at the rest of your items from 2 to 4 in your workbook and determine what would be the best monitoring for the hazards that you have identified there. Now, lastly, we are going to look at risk review. The definition of risk review is a formal assessment of something with the intention of instituting change if necessary. Why would we need to do a review after a project? Well, this is in order to see if the controls we implemented worked well, or if there are changes that are needed. Any system can benefit from a good review. It's said that this only happens when an incident or accident occurs. So when a review of documentation is needed, treat it as an opportunity for the continual improvement of your system. This method is best used in the PDCA format: plan, do, check, and act. Well, what does this mean? Well, in order to do a review of what has just been accomplished, we need to plan for a formal review. This is taking all documentation as well as any additional monitoring of the risk that was performed, all that additional documentation, daily safe task instructions, plan task observations, mini risk assessments, anything that helps you to understand what happened on site, and then also how was it accomplished on site. Was there any incidents or accidents, near misses, anything reported that could have gone against your safety procedures? Take into consideration the employees' information as well. A lot of information from employees is derived from how they perform the work in accordance with the procedures. You see, sometimes a change might be needed in the method of how we thought the job was going to be done compared to how the job was actually done. And once we've planned to do this, we need to take out the time and actually then perform the review. Do this in a quiet format, having the time set aside so that you can really almost audit all of the information that you now receive. And then check whether it was actually effective or if there's something that needed to be changed. If nothing needs to be changed, is there a possibility that you can improve on it for the next task that you need to perform? Remember, if you find any weaknesses or even room for improvement, act on this. The PDCA method means that after we've checked, even if it is fine, we still act on the improvement methods. And how do you act on it? Well, you do a plan. You then execute your plan by doing it. You then check if your plan is working and act on any remedies. This PDCA cycle will help you to become not only the best plumber, but the safest one.